All right, let's continue with two-way tables. So the reason it's called a two-way table is because people were surveyed or two pieces of data were collected. These are concession stand sales, and somebody tracked what kind of food was ordered each time and what kind of drink was ordered each time. And they wrote down how many orders of each thing. So again, using set notation, we're going to talk about the number of sales total. You're always going to find that in the bottom right-hand corner. Sometimes you have to do the totaling yourself, but you can add, so you're in great shape. So there were 400 sales total in this collection. Okay, the number of sodas sold. So when you look at this right here, you can see that total here, 200. It's at the bottom of this column. Number of pizzas at the end of this row, 182. Really easy to see. Number of things that were sold that were not pizza. Well, that would be hot dogs or people who bought no food. So you would add those two things together. 218. Okay. What about an or statement? Soda or water? Well, you have 200 soda sales plus 140 water sales. That's 340 soda or water. There's no overlap there, so you're fine. Okay, these must be people ordering individually. All right, number of soda and pizza. Let's consider this. So these are orders that included a soda. These are orders that included a pizza. So 120 is the number that included both. Remember, you could write this as soda, pizza, and the and symbol or the intersection symbol would say both. Okay, soda or pizza. Let's have a look. So 200 people ordered something with a soda. 182 ordered something with a pizza, but look, I have double counted these 120 people in here. So I have to subtract them off. Okay, let's do the math real quickly here. It's 262. So there are 262 people that ordered soda or pizza. Please realize that you can also use the or symbol, which is the union symbol. That's supposed to look like an upside down U. Okay, the union symbol. All right, here's one that I thought was just questionable. The number of people that ordered no drink and no food. Well, that happens right here. There's 10 of those. And I'm like, well, then what were they doing at the concession stand? So I decided that they bought t-shirts or something like that. All right. Obviously, you can turn these things into probabilities by dividing by 400. Let's do that. Okay, so if you take all of these orders and you want to know the probability that someone walking up ordered soda, okay, so that would be 200 out of 400 possible sales that you had. The probability of someone ordering pizza was 182 out of 400. Not pizza is this 158 in this 60, which I think we said was 218 out of 400. Soda or water, that's this 340 divided by 400. Okay, soda and pizza, that's this 120. Okay, soda and pizza divided by the 400. Now let's talk about or. Okay, soda or pizza. So you have your soda people, you have your pizza people, but look who I counted twice. I counted these 120 twice, so I have to subtract them out. So that is, what did we say, 262 out of 400? Okay, so I'm adding soda plus pizza minus the overlap or the both. This was soda plus pizza minus both. Okay. Pardon me, let's find the probability of water and no food. So these people just walked up, ordered water, and walked away. So here's water and no food. That's 20 out of 400. And lastly, water or no food. So we have to, again, do our calculation. This would be 140 out of 400. The no food people are 60 out of 400. And oops, I double counted them. Okay, I think that's 180 out of 400. Water or no food. Okay. All right, let me give you guys an opportunity to try this. Let's consider this two-way table. This is middle school kids and whether or not they play an instrument or a team sport or not. So when you ask somebody, do you play an instrument? Do you play a team sport? And you want to set up these tables, you have to have columns and rows for the not answer. So you have to be really careful about giving people enough places to answer. Okay, so let me give you a moment to try this. Here are your answers you can check. Okay, so did you get those answers? Okay, lastly, we've seen this before a little bit, this idea of adding together two things and subtracting off the overlap. You just don't even realize we did it. Let's talk about it with rolling this dice, okay? We've seen it before. Here is the sample space for rolling a six-sided die. 1, 2, 3, 4, 5, 6. So the probability of rolling a 3, well, there's one outcome that's desirable in that case, 1 out of 6. The probability of rolling an odd, well, in that case, there are 3 outcomes that we like. Okay, so it's 3 out of 6. Now let's try the and. The probability of rolling 3 and it's odd. Okay, well, there's one outcome we like here. It's the 3. So one outcome out of 6 is reasonable for us. That's the intersection. Now let's try union. Probability of 3 or odd. Let's have a look at this. Does this thing work? Can we add these together and subtract off the overlap? So let's find the probability of rolling a 3, add the probability of rolling an odd, and subtract off the overlap because we don't want to have that in there twice. That equals 3/6. And is that 3 or odd? Well, that would be these 3 guys. He's already counted. So yeah, 3 out of 6. It works. Okay, thank you very much.